Hello and welcome, people of the internet and programming enthusiasts. Today we are going to be exploring some of Python's built-in functions and why you should be using them. If you've completed your Data Structures and Algorithms 101, you know that programming often involves iteration, which is going over sequences of data such as lists and tuples and whatever. When it comes to Python, traditional loops like for loops and while loops are perfectly fine, but there is a way to avoid repetition and perform operations without explicitly writing loops. The first of these built-in functions we'll be discussing is map. Now, map takes an iterable and applies a given function to all the items contained inside it. This is useful for modifying or transforming data. Imagine you have a list of car models, let's call this list car models, and populate it with some model names. We'll just go with Ferrari for now. Now, we know that these car models belong to Ferrari, but the outputted list would not say that. Let's use map to append the Ferrari name to these models. As we discussed before, map takes a function and an iterable as arguments. We have our iterable car models. Now let's create our function. We will call it apply manufacturer, and it will take an argument of model name, and we will return an F string with the text Ferrari and the model name. Now we need to store this modified list of names in a variable. We will call it cars and apply our map function using the apply manufacturer function as the first argument and the list of car models as the second argument. When we print the cars variable, notice how it is a map object. A map object is an iterator, meaning the result of this operation is not stored in memory at once. It is simply a memory address of the iterator object itself. To solve this, we can just convert cars, which is currently a map object, into a readable list. When we run it, we see a nice little list of Ferraris. Let's try something a little bit more complex. Say we have a list of dictionaries and we'll call it people for now. This list has two dictionaries inside it with a name key and an age key. Let's say we want to get the year the person was born and add it as a key to that dictionary. Let's import the datetime and time delta module, and we can write our function to get the birth year. We will call it apply birth year, and it will take an argument of person, which would be the dictionary containing the person's details. Now we create a new key in that dictionary and we will call it birth year. This is not an accurate way of getting somebody's year of birth and is just for demonstration purposes. So just keep that in mind. To get their birth year, we can subtract their age in weeks from the current date. Because there are 52 weeks in a year, we can just multiply their age by 52 and access the year attribute of that datetime object. Now that we have assigned a birth year for that dictionary, we can return the dictionary itself. Let's create a new variable for the people with birth year and use our map function with the apply birth year function and the list of people, and we can add a print statement just to output that list. When we run this, we can see that we have modified that dictionary without explicitly using a loop Just bear in mind that instead of a fully defined function, you could also use a lambda function. I wouldn't recommend it for maintenance and debugging reasons, but you can do whatever you want. Now let's take a look at filter. Filter is self-explanatory. It can be used when you want to filter elements from a sequence based on some sort of condition. Filter returns only the items for which a condition is true. Like the map function, it takes a function argument and an iterable. Let's use our list of people as an example and try to find the people who are above the age of 18. Let's add another person to that list and just make sure their age is below 18 just for testing. We can write our function and just call it above 18. This function will take a person argument and we can just simply access the age key of that dictionary to check if the person's age is greater than 18. Now let's store our filtered list as people above 18. And we can call the filter function with our above 18 function and our people list. Now we can print it and see a nice little filtered list of people above the age of 18. Next, let's take a look at my personal favorite, zip. It's also the simplest since it just combines two or more iterables. Now let's say we want to add a year to those Ferrari model names. We can use our car models list and create a new list called cars with years. We can populate them with some model years for these cars. Now we create a new variable and let's call it model years. And we can use the zip function using those two lists. And if we print out our model years variable as a list, we see a list of tuples. This is because zip returns a zip object, and when you wrap it in a list, you get a pairing of the two input lists. Another simple built-in function is enumerate. Enumerate is useful for keeping track of a count in a loop or accessing the index of the iterable. Take our car models list again. If we were to iterate through items in that list, we could use a for loop. However, when using enumerate, since it gives us access to that index, we need to create a variable for that index. So our for loop would look like this. And when we print out the index and car, we can see the index for that item that was iterated over and the car itself. Enumerate also allows you to set the start point for the index as a keyword argument. Let's just set our start at 22, for example, and see how our output changes. Our first element now has an index of 22, and increments by 1 for each additional item in the list. These last two we are going to be looking at is any and all. These built-in functions only return a Boolean value. All checks if all items in an iterable is true, and any checks if any item in an iterable is true, like map and filter. These also take a function as an argument and an iterable. Let's go back to our people variable. Let's use any to see if any of those people have the letter M in their names. We need a function, so let's write one called has letter M. And this function takes a person as an argument. Now let's create a variable and let's call it has an M. We can call our any function, and for any person in the list of people, check if they have the letter M in their name. When we print it, we get true because there is at least one person in that list who has the letter M in their name. This looks complicated, but let me break it down in a lengthier way. Let's write a for loop to iterate through each person in that people list. We can write an if statement to check if the person has the letter M in their name by accessing that name key. And if they do, we can append a Boolean of true to that list. If not, we can append false. When we print this out, we see a list of Booleans. And if we look closely at the people list, we see the name Sam has an M, so is true. The name John does not have an M and is false. The name Tim has an M and is true. If we use the any function on this list, we can expect the output to be true because any item in that list is true. If we create a list of Booleans, call them bools, and set them all as false, print out an any function call on that list, we can see the output is false because none of the items in that list are true. All works in the opposite way. If all items in a list are true, then it will return true. If we use our previous example function and create a new variable called all have M, call the all function using that function, and print that variable, we can see the output is false. This is because not all items in that given sequence have an M. The same applies to the bools variable. Since all are false, when we call all on that list, it is false because all items are not true. If we change the list to all be true and print it out, we see that the output is then true because all items are true. I know I said true and false a lot, but once you actually look at the code, it will become a lot more clear. Unfortunately, that's all there is for now. Thank you very much for watching. If you have any questions or concerns, please feel free to leave it in the comments and don't forget to subscribe. As usual, I will leave a GitHub link in the description if you would like to have a look at the code. Until next time, take care and goodbye.